So the topic of this video is looking at an advanced function. So we've covered how to do basic functions, which hopefully you understand. So if I wanted to teach my program to do something that it would do over and over again, I would say public void some function. I may have some parameters or arguments to pass in here. That's the information that my function needs to do its job. And then in here, I might do whatever. Okay. Now, I've taught my program to do this function. It doesn't actually do it until somewhere in my code I actually ask it to do it. So if I run this program, you'll notice whatever pops up, and I can do that multiple times. So that's basic functions. Today what we're going to be talking about is something called recursive functions. And recursive functions are an advanced computer science concept. So I'm going to give you a basic example of what recursion might look like. You might remember this from math. If you don't, factorial. So if I say 6 factorial, and let me make this a little bit bigger. In math, what factorial means is I'm taking 6 times 5 times 4 times 3 times 2 times 1. And I'm multiplying them together. So 8 factorial would look something like this. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, what recursion is a way of calling functions, or of creating a function so that it calls itself until it reaches a base case. So I could code this using a loop, so to loop until, from 6 down to 1 and keep multiplying the result. I could do this inside a loop. But today what I want to do is something called recursion. So what recursion is, I'll give you an example. If somebody said, 6 factorial to me, and asked me to give the answer. So for example, if you ask the computer to do this, the computer might say, sure, I'm just going to multiply whatever 5 factorial is. Okay? So you notice it says, yeah, that's fine. I'll figure out what 6 factorial is. Someone has just got to tell me what 5 factorial is. Of course, that someone is still the computer, but you get the idea. So on the next line, what happens is the computer, again, has a very short memory, somebody passes them this 5 factorial. So inside of 5 factorial, what they're going to say, yeah, sure, I can get you the answer to 5 factorial. Someone's just got to tell me what 4 factorial is. And then again, as you guessed, the computer's going to get this note from itself saying, hey, can you help me out and tell me what 4 factorial is? And the computer's going to say, yeah, sure, I could tell you what a 4 factorial is if you could tell me what 3 factorial is. Okay, and you can see every step of the way I'm just calling the same function over and over again until we actually get to a base case, and we'll get to that base case. Now, this guy's going to get to a base case where it's 1 factorial, and we know what 1 factorial is. 1 times itself would just be 1. So now that we've reached this base case, we know that 1 factorial is 1. That's an easy answer to return. We can start returning the numbers up the chain of command, like basically passing the notes up the levels of the computer until we reach the original person that asked, which was the 6 factorial, and then we can get an answer. Interestingly enough, there's actually 2 base cases with factorial. 1 factorial, we know 1 factorial would be 1, and then 0 factorial would also be 1. So if you want to ask your math teacher about that one, you can. So we've got two base cases. Let's see what that looks like if we actually start coding it. So I'm going to create my recursive function here. It's going to be an example of factorial. So I'm going to say public, and it's actually going to have to return a value here, which will be an int factorial. And we're going to take a number in as a argument. Okay, so basically what this factorial is trying to do is do the same thing as figure out what 6 factorial is and say 6 times 5 times 4 times 3 times 2 times 1. So here's how this works. I'm going to do an if statement. If num equals 1, and actually I'll do our advanced, if you watch the advanced if statements, if we want to do multiple conditions, or num equals 0, I'm going to return 1. Okay? Because if someone said to you, what's 1 factorial, you can tell them immediately the answer is 1, or if somebody said, what's 0 factorial, you could immediately tell them the answer is 1. So, if it's one of those two numbers, it's easy. Else. Now this is where we have to ask ourselves some questions. If it's greater than 1, and actually I'll say if it's else if, and we can talk about an error in here later, else if num is greater than 1, we might need some other answers. So I'm going to say return, actually I can say int answer equals num times factorial. Basically it's calling itself num minus 1. Okay, now this is what I was explaining at the start here. So basically, instead of saying, 6 times 5 times 4 times 3 times 2 times 1, our program says, okay, you're asking me for 6 factorial. I'm going to multiply 6 times whatever the answer to 5 factorial is. And if we follow the chain of command of it, it just keeps asking itself the question. It puts it on the execution stack in the computer. The next time the computer gets that, it's like the computer gets a piece of paper from itself and saying, okay, what's 5 factorial? Well, it says, okay, it's 5 factorial is 5 times 4 factorial. Then it gets the piece of paper saying, what's 4 factorial? It says, okay, 4 factorial is 4 times 3 factorial. And then it gets the piece of paper and says, what's 3 factorial? 3 is 3 times 2 factorial until it gets to one of our base cases. And then it starts returning the answer all the way up the chain of command. So I say int answer num times factorial num minus 1. So basically what I'm saying is, yeah, if they, let's assume they passed in the number 6 here, it's greater than 1, I'm going to say, yeah, my answer is going to be 6 times whatever the answer to 5 factorial is. And then on top of our execution stack in the computer, it'll get 5 factorial. So it'll say, okay, yeah, that's greater than 1. The answer is 5 times whatever 4 factorial is. And then it'll come back up to our execution stack and it'll say, okay, what's 4 factorial? It's 4 times whatever 3 factorial is. Until it gets to the point where it returns a 1. And then at that point, it returns the answer up and we can get our answer. So I'm going to say return answer here. Now, what happens if our user asks for a number that's less than 0, like a negative number? I don't want to get into a big math lesson here. You might ask your math teacher about this, but if it's less than 0, it's basically undefined. You can't do negative factorial, so we're going to say return 0. So we're just going to say that number doesn't exist, or we're just going to give them a 0 answer. So let's see what our answer is. So I'm going to try int ans equals factorial. Let's see if it works for factorial 1. System.out.println. Okay, let's run it and see if it works. Yeah, factorial 1 factorial is just 1. 1 times itself is just 1. Okay, so now copy and paste this, and let's do for a couple other numbers. Actually, let's try 0. Okay, so we can see 0 factorial is 1, 2 factorial is actually 2. 2 times 1, right? And then we can keep going from there. So let's actually get the answer to 6 factorial. 6 factorial is 720. And we can actually check that on. So if I go to Google Calculator, we can see 6 times 5 times 4 times 3 times 2 times 1. We get 720. So our program is executing correctly. And actually, if we want, so that should be 6 factorial. And then let's paste one more and let's go crazy. 10 factorial. And you can see how big the numbers get. So that's what a recursive function basically is. It keeps calling itself, right, until it gets to a easy, simple base case solution. So if somebody asks me what 6 factorial is, and says, yeah, sure, I can get the answer to that. You just tell me what 5 factorial is. And they might just pass me the same note and say, what's 5 factorial? I say, oh, yeah, I can get the answer. You just got to tell me what 4 factorial is. And they keep passing me the answer, and I'll give it back to them eventually. Really, the computer ends up doing all the work, but it's a recursive function. Now, what you have to be careful with a recursive function is that you don't get into an infinite loop situation, so where you don't get a base case. So if I took out, the num equals 1 or the num equals 0, if we never reach that base case, our program would just keep calling itself forever and would enter kind of an infinite loop. Now, the other thing we should take a look at, and let's see what the stack looks like. So we'll start printing off some messages here. Actually, just so this runs correctly, I'm going to want to put this over here. Because if you follow the execution, it'll... Okay, so let's run that. Let's comment out all these other ones. And just look at what kind of the stack might look like for 6 factorial. So, 6 factorial, right? Reach the base case, returns our answer. So recursion, this is an advanced topic in computer science. I'm going to post on the e-learning site this reading right here on recursion. I'm going to encourage you to read over that. I will post some other videos on recursion as well, but this really represents a different way of kind of thinking about problems, where you're trying to break it down into smaller and smaller pieces until you reach an easy piece that you can solve. And there are some programming languages out there that are strictly coded in recursively. So you might look up a language like Lisp, and I believe Ada might be completely recursive. So take a look at those. Challenge and assignment will be posted on the e-learning site.